Hello. Today I'll be talking about plotting points. Plotting points is important because without knowing how to plot points on a Cartesian plane, you will never be able to really understand the full meaning behind the Cartesian plane and its algebraic meaning. Plotting points is a very simple unit and it's very not hard to learn. So today I will be teaching you exactly and how to correctly plot points. Now I'll give you a summary of the Cartesian plane. So basically, on the Cartesian plane, there's the x and y axes. The x-axis, when it gets lower, it changes to negative numbers, and the x-axis, when it goes to the left, changes to negative numbers. So basically, the way we plot points is by taking each number on the x-axis and the y-axis and putting them together to plot a point. So, but always remember, the x-axis always comes before the y-axis. So, for example, let's have a quick example. Let's say let's just make a coordinate 1, 5. 1, 5. So as we can see, as I just said, x-axis always comes before the y-axis. So x-axis and y. So x is 1. So now you can see 1, and the y-axis is 5. So we bring it up. 1, 5. Not hard, right? Let's do some examples. Before we move any further, we need to look at the Cartesian plane. In the Cartesian plane, there are 4 quadrants. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. These quadrants move in a counterclockwise formation. So don't ever forget that they're counterclockwise and accidentally do them clockwise. Now, let's get into some examples of plotting some points. Okay, let's take the first point. 1, 6. So as we can see, x is 1, y is 6. So let's go 1 and then 6. Pretty easy. Let's go to the next example. X is 3 and y is 4. Okay, so 3, 4. Pretty simple. Next question. 2x is 2, y is 5. X 2, y 5. Okay. Next example, 1, 1. 1 on the x, y on the 1. So it's going to be right here. Next question is 4, 3. So x is 4 and y is 3. So 4, 3. Now we're going to get into the negative numbers. So negative 3, negative 4. Negative 3, negative 4. Pretty simple. Next, negative 6, 6. So negative 6, 6. Now I will be talking about the equation of a line. The equation of a line is very closely intertwined with plotting points on a Cartesian plane and finding the slope. So let's dive into it. What is the equation of a line? The equation of a line is y equals how far up x equals how far long m equals slope or gradient, b equals value of y when x equals 0. Now let's dive into the types of line equations because there are 3 main types. So let's get to the first type. First type is slope intercept form. Slope intercept form is y equals mx plus b. The next type of line equation is the point slope form. Point slope form. Point slope form is y minus y equals mx minus x. And then finally we have standard form. standard form is ax plus by equals c. Okay, now I will show you how closely intertwined the equation of a line is with plotting points. For this problem, we are going to use the slope-intercept form to calculate the slope of the graph. So let's start off with a basic point. Y equals 2 over 3x plus 2. So basically we need 2 points in order to graph the line. So now we can use that y-intercept is, so as we see, because y equals b is the y-intercept form. So this right here is the y-intercept. So 2, so we can get a basic point which is 0.2. So we bring it up, we plot it at 2. So now that we have 2, we can calculate m is 2 over 3x. So 2 over 3 is 2 is the rise and 3 is the run. We need to plot the second point on the line by starting at 0.2. The first point, then move up 2 units to the right, the rise, and 3 units to the right. This gives us a second point at 3, 4. And just like that, if we move it like this, we have calculated the line. The way we solved this problem is basically we used 2 because in slope-intercept form, 2 is b, and b is the y-intercept form. So now that we knew that we got our first coordinate, which is 0.2, so we plotted it down. And then we used the m, which is 2 over 3. 2 is the rise, and 3 is the run. So basically, we rose 2 and we moved 3. In this equation, 2 was the value of y when x equals 0, and m was the slope for the gradient.